In this video, we will learn about the change of liquid into gas, that is the process of vaporization and boiling. So whenever a liquid changes into gaseous state, we call it as vaporization, and vaporization can happen in two forms, that is boiling and evaporation. So let us learn about boiling. So when we supply heat to a liquid, whenever we increase the temperature, we know that the kinetic energy of the particle, it increases. So it means the constituent particles, they start moving faster, and due to increased intermolecular collisions, some molecule of the liquid acquire enough kinetic energy so that they break free from the attractive forces of the molecules, other molecules, and they escape into the space above the liquid. Means the attractive forces are becoming weaker now. So thus liquid changes into gaseous state, and when we continue heating, a certain temperature will come when the molecules from the bulk of the liquid, they will gain sufficient energy to change into gaseous state. And at this stage, bubbles will start to form within the liquid which rise to the surface, and there is rapid vaporization. This phenomena is called boiling of the liquid, and the temperature will remain constant during boiling, although the liquid is being continuously heated, until all the liquid has been converted to gas. The temperature will remain constant, and this temperature at which liquid starts boiling at 1 atmospheric pressure is called the boiling point of the liquid. And we know the boiling point of water is 100 degrees Celsius or 373 Kelvin. So boiling point of a liquid again is a measure of force of attraction between the constituent particles. Means higher boiling point means that there are stronger forces of attraction present between the constituent particles, and vice versa. Also, a pure liquid has sharp and definite boiling point. Therefore, boiling point of a liquid is used as a criteria for the purity of the liquid. So here we have seen that like melting, temperature does not change during boiling, although the liquid is continuously heated. Means the temperature remains constant until whole of the liquid is converted to gas. Now why it is happening? Because when the liquid is heated initially, the heat supplies increases the kinetic energy of the molecule. But once the boiling point is reached, means once the liquid start boiling, now the heat supplied is used to overcome the forces of attraction between the molecules, and liquid changes into gaseous state. But the average kinetic energy remains constant, that is why the temperature remains constant. So this heat absorbed, which is absorbed in changing a liquid into gaseous state at the boiling point, is called latent heat of vaporization. So we can define latent heat of vaporization as the amount of heat required to convert 1 unit mass of a liquid into vapor at the boiling point without change in temperature. The SI unit remains joule per kilogram, and in SI unit the latent heat of water is 22.6 into 10 to the power 5 joule per kilogram. It means to convert 1 kg of water into 1 kg of steam at 100 degrees Celsius, 22.6 into 10 to the power 5 joule of heat is absorbed. So sometimes this question comes that why does steam at 100 degree cause more severe burns than water? So the answer lies in the concept of latent heat. So steam at 100 degrees Celsius has more heat content, because when water has boiled and it has converted to steam, so it has absorbed the latent heat. Means all that latent heat, it is present in the steam. Although both are present at 100 degrees Celsius, but the steam that is present at 100 degrees Celsius, it has more heat in the form of latent heat. So that is why when steam comes in contact with the skin, it will release more heat than boiling water, and that is why steam causes more severe burns on skin. So we should know that a pure substance has definite melting and boiling points, and no two pure substances will have same melting and boiling points. Therefore, melting and boiling points are used as the criteria of purity of pure solids and pure liquids. Then there comes this process of condensation, which is opposite of what we have discussed, that is opposite of vaporization. So it is a process in which the vapor changes into liquid, and this will happen on cooling. So on cooling, the gas or the vapor particles, they lose kinetic energy and they come closer, which increase the order of the system, which ultimately forms clumps of molecule and it changes into liquid state. So condensation is an exothermic process. Exothermic process is the one in which heat is released. So when condensation happen, so heat is given out to the surroundings, and condensation of water vapor is the reason why windows become foggy on a cold day, because all that water vapors, they become condensed and they come on the windows. So I hope this topic is clear to you. Thank you.